Good morning. Good morning to everybody. Good morning to all of you. See, there is a change in the schedule which I have sent a message through WhatsApp group. Today, first session will be, first session speaker will be our beloved principal, Dr. H.R. Mahadeva Swamy, sir, and he will be presenting on new possibilities with Blue Ocean strategy. And immediately after the first session, all participants have to log on to Atal participants web portal, and you have to give feedback about the program. And after exercising feedback only, the participants are allowed to take tests. That's how it was designed. Giving feedback is a must. And after giving feedback, we shall have the test. And after completion of a test, we shall have validatory function. It will be an extended session from 1 to 2. We shall have the validatory program. Today, first session will be by our beloved principal, Dr. H.R. Mahadeva Swamy, and we will be beginning in another 3 minutes. Okay, thank you. Okay, very good morning. Good morning to all of you. I welcome all the participants of this 5 days faculty development program sponsored by Atal AICTE. It's on Blue Ocean strategy to this 5th day session. I welcome Dr. H.R. Mahadeva Swamy, sir, our beloved principal of JNNCE College of Engineering, Shivamogga, to this session, and he will be the resource person for the first session, and he will be speaking about new possibilities with Blue Ocean strategy. It's about innovation. And really, I'm happy to introduce Dr. H.R. Mahadeva Swamy, sir, to all of you. Dr. H.R. Mahadeva Swamy is a result-oriented person with 28 and odd years of proven experience in teaching, research, invention-based research, intellectual property creation, filing and licensing, DSP, image and video processing, software development, system test, automotive infotainment, embedded system setting up and managing offshore development centers and administration as well as management. And he did his engineering B from Sri Jayachamranga College of Engineering in electronics and communication engineering with first class in the year 1987. And he completed his MTech in industrial electronics from National Institute of Technology, Surathkal, with distinction in the year 1992. And he completed his PhD in engineering, and his area is fractal and wavelet image compression from National Institute of Technology, Calicut, in the year 2000. And he had worked so many organizations, Applied Inventions Private India Private Limited, and he worked as MD and CEO. And creation and monetization of IPS was his role. And next, Curio Systems Private Limited between 2013 and 16, and he was the director and software development in that company. And between April 2003 and October, he worked in October 12. He worked in Robert Bosch Engineering and Business Solutions Limited, and he worked as group head responsible for projects in car multimedia systems, machine vision systems for industrial automation and security systems. And here he was a lead with a size of 200 plus software engineers. And later he worked with Satyam Computers Services Limited, Hyderabad, and he worked as a project manager leading teams in DSP and image processing area, pre-sales, business scope study, proposal making, and system architecting. And he worked in Siddharanga Institute of Technology, Tumkur, between April 88 and 97, and he worked in the Department of Electronics and Communication Engineering as assistant professor, and he was involved in research, supervising projects, and consultancy work. And his achievements are: he established a business in verticals such as telecom manufacturing, automotive, industrial technology, security system, starting from business development to operations, established new opportunities in car infotainment connectivity, leading to setting up a big team, and demonstrated business innovation by forming the highly competent team in DSP, image, and speech. And he was an invited speaker at various conferences and university events, and he was a task force member of MNC to establish Global Research Center in India. And a few other organizations he worked and associated with are Robert Bosch, USA, Germany, Robert Bosch, Malaysia, Tech Mahindra, Wipro, General Electric, Assist, USA, Caterpillar, Tata Elxsi, TRW, Connexent, India, and Mitsubishi, General Motors, Ford, Volvo, JLR, Volkswagen, Audi, Nissan, MAN, Tata Motors, Renault, PSA France, Blapank, RVC Bangalore, SIT Tumkur, VRSCC Vijayawada, IIT Chennai, Lekha Wireless, Value Labs Hyderabad India Private Limited in 2012, and Curio System Private Limited in 2013. He was a visiting professor at BITS Pilani for Wipro Waste program and teaching various computer science subjects for master degree students. He was associated with universities and extended coaching as well as mentoring of faculty, consulting in creating invention-based research and creation of patents. He authored 17 research publications in various conferences and journals, filed 1 patent, curing 5 PhD scholars in VTU and Jain University. His research areas of interest are virtual reality, 3D point cloud, imaging technology, multimedia, Internet of Things, and cyber physical systems. He visited so many countries like Germany, Portugal, Malaysia for technical discussions for new product development. And he has professional memberships with IETE, life member of IETE, ISTE, and Institution of Engineers India. And is a fellow of Institution of Engineers India. Attended many programs and competency enhancement training programs with total programs over 60 numbers, and the number of days are 200 plus. Dr. Mahadeva Swamy has participated in competitions, events, conferences, and won many prizes. And his hobbies are reading books, social work, learning on investment, networking with friends. And is born in 1965 and is married to Anita, madam, and a graduate and investor and a homemaker, having a talented daughter who is pursuing her master's in computer science and is a graduate from RVC College of Engineering in Computer Science. And she's pursuing her master's in University of Southern California, Los Angeles. And his son is pursuing 10th standard. This is a very brief profile about our beloved Dr. H.R. Mahadeva Swamy, sir, principal. Now it's over to Dr. H.R. Mahadeva Swamy, sir.
Yeah, thank you, Basiraj, for a very elaborative introduction to the audience. So, good morning to everyone, and good morning to all the participants who are here. So, this is the 5th day of the workshop FDP. Today we are coming to an end. I'm sure this Atal AICT FDP is a wonderful learning platform, especially on the topic of blue ocean strategy, where a lot of sessions have been conducted so far by experts and resource persons from different the area and different industries. Maybe this in this session, I think this is the last session of the FDP. So where you heard of what is a blue ocean strategy, what is blue ocean, what is red ocean, then what are the tools available, and many things is covered by various resource persons so far. So now just in this session, I want to touch upon is what are the new possibilities with the blue ocean strategy, and I'll be mainly focusing on IP, that is intellectual property. So this is the topic which I take up. Maybe what I do is I'll just quickly, I'll not take much time. So maybe I'll end up by 11 o'clock or something, 11:05, maybe 45 minutes to 50 minutes. So I just touch upon what is an IP, and then I'll go to the topic of what are the new possibilities which you can work or create with the blue ocean strategy. So this is how the flow is. Okay, so this is the probably you might have heard of inventions. And I call upon this as an invention-based research. So once you do research, how do you do the protection, and how can we use this IP for a commercialization? So this is the thing which I cover quickly. Maybe I'll take about 25 minutes for this. Maybe then I'll move on to the using the how we can create this using a blue ocean strategy. Okay, so just if you look at this is the flow, I'll just touch upon what do you mean by invention-based research, and what is invention protection, and what is IP, then what is the patent process and IP commercialization. So if you just come to the innovation ecosystem, maybe if you just look at, say we have the model is like this: input, there will be input, there will be output. So in between that, what happens is called interaction fields. If you look at, one is the input. So input will be like basically a knowledge creation, basic and translation research. So what all the academic institution or industry does. Then output would be like basically people look at the jobs, then the wealth creation, commercialization of the technology, commercialization of the research what we've done, and some creation of the new product or the services, new markets, and creating the new companies. This is the output. So in between that, maybe between the input and output, there will be 3 boxes which are written there. So one is the once you have a knowledge creation happens, or once you have an idea, once the innovation comes in, or once the invention happens, or once the research output comes, then we'll try to make the proof of concept, because nobody will touch up. We use as it is. For example, I did a research, so that directly cannot use that in the field. For example, if anybody make any dish, so somebody has to taste it, whether it's okay or not okay, whether it's a salty or the like it's a sour or whatever. So somebody has to test it. So taste it. So like that, there is a called as proof of concept. We call the proof of concept, or POC, or the prototyping, whatever you call. So then we have the education, maybe how this happens. So in between input and output, how this happens is basically by education, using human resources, human network of funds, so many things. I think not one industry, university industry collaboration, IP strategies, all the things in what is called interaction fields. So in this box, a circle, many things happens. So then comes the proof of relevance. Before it goes to the output, proof of relevance. That means whether relevant to which area is relevant to the market, which area it is relevant. So we make a proof of relevance. So this is what is called the innovation ecosystem. Okay. So this stresses the flow of technology and the information among people, enterprises, and institutions, which creates the vibrant innovation system. So I'll come to this point later, maybe in detail. So this is the innovation ecosystem. Now, so what is the major role of the research universities? Maybe I think all of you are aware. Now we have the new education policy defined by the government of India, new education NEP 2020. So it's a buzzword today. Then each state is they're going to roll out this NEP 2020 in the coming years. And of course, this new education policy is new to India, but this only exists in the Western countries. For example, if you take the Europe or if you take the US, this particular thing is already available. But now today, from this year onwards, maybe in India, we are going to roll out the new education policy. So as per the new education policy, so most of the institutions today are the teaching institutions. So you take any institution, whether you take a college or you take the universities or take the institute, most of them are the teaching universities. Maybe very few, maybe a couple of institutions, like a couple of universities, are also focusing on the research. They're not the research universities, pure research universities. But so they want now, as per the new education policy, what is defined is, so we have to become the teaching and research university, not teaching and research institution, a teaching and research college, not just only a teaching institute. So when that comes into the practice, so the major responsibility comes to the universities. That means primary driver of any economy of the country and the job creation can be done only by innovation, largely driven by science and technology, science and engineering. Okay, so the global economic competitiveness requires the confluence of the scientific discovery, which creates the knowledge and technological opportunity and workforce talent, access to the enabling resources. This is basically the responsibility of the importance of the major universities. Okay, having said this, so what is the technology? Maybe when I say technology is very important for a key, it's a very key to the economic growth and international competition. So today, why India we are not for the ahead of any other country is because the technology is very poor. And though we have a technologist, we have a people, we are not creating the technologies. Most of the technologies we are borrowing or buying from different countries. For example, China, US, Russia, France, Europe. Many countries we are buying the technologies. Whether you take the defense, take the space, take the the telecom, take any area. Most of the areas we are buying or we are borrowing from somebody else. Even the medicine. Okay. So now, so what is that is required to be done? Research must be exploited to produce new product and these devices. So that means the technology transfer becomes a very vital. And especially today, when time to market is key to success. For example, many of the time to market is very important. Today, if you are developing a new solution, new service, it has to go to market within the next 1 year, 2 years. For example, you are seeing the today's situation, pandemic situation. So people are talking about the COVID vaccine for the COVID. So now, what is the time to market? People want it in 1 week. People want it in 1 day. If you are able to give the solution in 1 day, the people take it. But that will not happen in 1 day. So that means it may take weeks, it may take months, it may take years. So that is what is called time to market. Okay. So now without scientific curiosity, there is no technology transfer. So now, so when continuing, so what is required is continual innovation, and technology will become the outdated. If you don't do that innovation, if you don't do the invention, the technology becomes outdated. That's how the technology is focusing on the improving. Okay, so having said this, so what we had, so if you look at in the past, so you have in 1975, you had a computer. Maybe the computer was filling complete room of size of 100 by 200 is the size of the computer. Today, by just I have an Apple device, so which is equivalent to the whatever we had in the 1975, much more than the whatever we had, and available. So at that time, the computer was costing in 1975 close to $5 million. Today, if you give the $400, you will get the Apple device, which is more powerful than what we had in 1975. And today we have, I think, in the 2012 and the survey done, we had about 230 million knowledge workers. When I say knowledge workers, software engineers, the teachers, the faculty, and many people. I think that's a number is increasing. Then if you just come to the other part, in the US, they spent about $2.7 billion for doing this human genome project. This is one of the pet project of the US government, which is already the research is done, implemented, already in the market. So which is called human genome project. I'll come to that point in the later stage. So that is one project. It took 13 years to complete this project, then they come into practice. So similarly, if you just look at it today, people are talking about the autonomous cars. So normal cars also there, autonomous cars. So now this autonomous car, maybe Apple or Google or Tesla, many people are doing this. So more than 300,000 miles are driven with only one accident. Maybe it's very, very important. If we just look at this, why that's innovation. So when it comes to the solar power, so solar power, so today the solar power cell is available at the 85% drop in the cost per watt. So in 2000 it was $1. Today it is available with a $0.15. So that is how the cost is dropping. That means innovation or the invention is happening. Okay. So now, so if you look at what is the potential in 2025? So as per the McKinsey survey, so $5 to $7 trillion business by 2025. That is the knowledge workers, the mobile internet, whatever. Then mobile internet, if you come to mobile internet, people, more than 2 to 3 billion people will use access by the 2025. Okay, that is what they will get it. Now, so if you just look at the left part, there will be 1.5 million drivers caused deaths from car accidents in 2020 by 2025. So if you just see the previous slide, only one accident when they drove close to around 300,000 miles, there will be 1.5 million people who will die. Drivers will die because of the car accidents by 2025. So that means people are talking about the autonomous innovation in the autonomous car. So that is very much powerful. Similarly, the 16% of the global electricity will be generated by 2025 by a non-conventional sources like a solar, wind, and other things. Now coming to this one, the sequence with the human genome. So it was costing the $1,000 or $2,000 in earlier. Now today, by paying $100 and with a 1 hour, we can get the human genome sequence analysis. Even in India, it is available. For example, just to give a saliva of any human being, you will get your all genetic analysis done. So you get a human analysis, genomic analysis you can get. So by that, you know what is our character, what is our behavior, what is our health, what will happen, all things we will get it. So that is how the things are available. Today, human genomics is a very, very becoming a common, and then it has been done in India also, and also other countries as well. So cost has come down. The cost has come down to less than 100. Maybe sometimes even you can get a $50 also, even in India. Okay. So having said this, so what are the innovation opportunity? If you look at the innovation opportunity in disruptive technologies, so now McKinsey this made a survey and then identified 12 technologies that could lead to $20 to $30 trillion economic impact in the world by 2025. So that's an opportunity. Okay. So over the last 2 centuries, technology innovation has provided a major impetus for economic growth. I think all of us agree. Because if you look at today, the mobile has made a revolution. So today the mobile internet has made a revolution. Internet broadband has made an evolution, and they made the revolution in the telecommunications space. Today we are connected because of the innovation happened in the telecommunication. Okay, and then technological change could have a bigger role in driving India's the GDP impact than the advanced economies. Maybe if that's how the government of India for the last 10 years. So they're putting in, maybe if you just check the 1991, So from that onwards, so a lot of things are happening in the technological development in India. So now India is advancing, and India is becoming, the innovation hub, innovation-driven economy, and the GDP going to be more and more by the technology, maybe next 5-10 years. Okay. Now, so what are the 12 technologies if you look at? So one is the mobile internet. I think all of us know. So it is making a change in many of the areas. Then automation of knowledge work. So many of the things are automated. So intelligent software system that can perform the knowledge work tasks involving the unstructured commands and subtle judgments. That means many of the things using artificial intelligence, data science, and the machine learning, and many of the things, the automation of knowledge work is happening. And IoT, I think all of you know. And there's a network of low-cost sensors, including the human body, everywhere. The IoT is becoming agriculture and manufacturing or the defense. Everywhere the IoT is being used for data collection, monitoring, and decision making on many things. Okay, then cloud. So cloud technology, so you can put your data in anywhere, can use anywhere, any place. So that means the cloud technology is becoming popular. So using the computer hardware and software resources are delivered over a network. That means you need not to own your data center. So just to pay whatever you want about 1 TB cloud space, you just pay 1,000 rupees. You can get the 1 TB space, and you can access from anywhere. You need not have the server, you need not have a computer, you need not have a network, anything. So that's how these things are becoming. Okay, so that's a cloud technology. And then the energy storage. So this is one of the area which is now upcoming. So whatever the energy you basically like a dams to store the water what we have. Like that, energy storage is also becoming, because now today there's no storage devices available much. So if you want to store 1 megawatt of power, there's no device. So now if you want to store the energy, now it's evolving. So people are coming out with the devices to store energy in terms of megawatt, kilowatt, and other things. So where it be, so for example, today we are depending on the electricity board for electricity. So suppose if you want a power of 1 kilowatt or 5 kilowatt in a month, so where you'll get? You'll not get it. So you have to depend on the electricity board. So only we can get the battery UPS, which may last for about 2 or 3 hours, or you may get a 1.5 watts cell, which you can use for a few hours or few minutes. But you will not get the high power like a 1 kilowatt or 5 kilowatt or 10 kilowatt power. Maybe you have to have the generator or other sources. So now, so people are innovating, people are inventing how we can store the high capacity energy in terms of megawatt, in terms of kilowatt, hundreds of kilowatt. So this is happening. So a lot of things are happening. Maybe probably you can explore that particular thing. Then, as I said, renewable energy, generation of electricity from the renewable sources, like which is having an impact on the climate. So like a solar, wind, and many other things are coming up. Then, as I said already, the next generation genomics. This is becoming a low-cost gene sequencing, where advanced big data analytics and synthetic biology, like writing DNA, this is becoming a power. For example, today if somebody wants to marry, so it's a very Herculean task to get married. So maybe the boy and girl both. So now today what they do, so maybe there are multiple methods. So there's a love marriage or arranged marriage, whatever you have. So today people go with the astrology. So maybe the astrological match. Maybe they take the kundali, then they see that whether the boy is okay, girl is okay, then they see the match. So that's still, if you look at today, if you go to the family court, there are lakhs of cases filed for a divorce. So with all those things done, with the matching with the astrology and all those things, people have seen that, but still, there are a lot of cases filed in many of the cities. Lakhs of cases are family dispute. That means they want to divorce. Why? So because the people are not matching. So maybe today, the people are working on how we can use the genomics for making a matrimonial match to make the girl and boy suitable, whether their match going to match. Today, people are using genomics for a recruitment in the institutions and in the organizations. So whether this person who are going to recruit is suitable for our organization or not, they can make the analysis using a genomic sequence. And whether you want a personalized medicine, for example, somebody is having some health problem. So now, typically now, how they are working is we use the general medicine. That means the medicine invented or what is available, same medicine will be used for everyone. Now, if using a genomic analysis, people are developing the personalized medicine. That means the medicine, what is required for that person, will be developed. The companies, the pharmaceutical companies are using this genomics for developing the personalized medicine. So that's how the genomic is working. It's very huge potential, and human genomics, computation genomics, many things are coming up in this particular area. Then, of course, 3D printing, which is additive manufacturing techniques to create objects by printing layers of material based on digital models. Maybe today, if anything which you want to print, for example, you go to a dentist, you want to get the whatever root canal will be done, and they take the side, then they will take go to 3 or 4 days, you will get the teeth ready, then you will put it. But today, on the spot, you just take the measurement, you will print it within half an hour or 45 minutes, you will print the teeth, you will put in your teeth, put the teeth and send it back. So that's how the things are happening. So many things. I think people are printing everything in a minutes or in an hours. It's where you used to take about days or weeks to get the manufacture, get the mold, and then do the manufacturing. So today, people are talking about the 3D printing. Similar advanced materials. So I think if you look at the material used for a car manufacturing or the aeroplane manufacturing, name anything. So a lot of materials being used. The different materials are composite materials. Many things are coming up. So now strength, the weight, and conductivity, and the functionality. People are inventing new things, or innovating new things. And there's a lot of other things. Advanced oil and gas exploration, advanced robotics, autonomous vehicles is the one area where the people are talking about. Maybe next 5 to 10 years. So there will be no drivers required. So you just get into a car. You just tell you can. It says SUA coming. Speech user interface is coming. Just tell that I want to go from JNNCE to the Shumaga bus stand. It will take. So you need not to do. So just you plug in your credit card or whatever. Then it will take and then deduct the money from this thing. Then it will happen. So that's how the autonomous vehicles are coming up. There's a lot of innovation is happening. Okay. Yeah. So anyway, just skip this particular thing. Now, when you come to the research and innovation, a lot of areas. I think if you look at some of the areas are written here, but many other areas are available. Maybe energy, security system, clean water, green chemistry, IoT, cyber physical system, many areas are there. Okay. Now, so when you come to the research in academia and universities, the primary aim of the universities in the technologies to develop the technologies for solving societal problem and make a living better. So this is basically the objective of the research in the any university or the academia. Then once you develop that, you have to safeguard the intellectual property. For example, somebody is spending time, you are spending your time, valuable time, then inventing something, finding something, you're doing a research and finding something, then you have to protect it. So that is called intellectual property. That means protecting your ideas, protecting your whatever you have invented, protecting the whatever innovation you made is called IP. Safeguarding that IP. Then once you safeguard that, we can license it, we can commercialize it, we can sell it, we can give it to anybody for rent, we can whatever. So that is called licensing. Licensing of intellectual property rights and technologies to generate the revenue. So you get money out of it. And from meet the academic and research expenses, you can generate the revenue from the academic institution, can generate the revenue from that particular technology. Okay. So anyway, so if you just look at the past inventions. So aluminum was invented 100 years back, but it took 100 years to come into practice. So maybe basically utensils and the sailboats. So maybe it took 100 years. Similarly, if you take the total internal reflection, this was invented in 1881, but it came into practice in 1971. It took 90 years to come into practice. So theory of lasing, Einstein invented in 1917. It took 43 years to come into practice. It was a first one, a prototype gas discharge laser in 1950. Similarly, if you look at the X-ray, it came into existence within a few years. 1895 is invented and came into within 5 years it came into practice in a medical profession. So similarly, if you look at the radar was invented in 1914. Nothing happened for 35 years. Then when the World War was started, it's basically based on the need. We are forced to use it, whereas the previous one was not it was not forced. It came into existence. Whereas this particular thing, because they forced. So the World War was needed. This particular radar was needed. So that's how this the patent was, the technology was used in the during the World War II. So that is the thing. So now when you say the invention, basically invention is the original concept, and innovation is the development, a refinement, a change of an existing idea or the product. So that's innovation. So just make a small change or in the existing thing to the new thing. That is what is called innovation. And invention is basically original concept. Okay. So that's the basic difference between invention and the invention. So now why you want to protect your intellectual property? As I already told you, you have to protect this thing because you invested time, money, and other resources to create your new contribution to the technology. So that's how we have to protect this one. So somebody says, I don't want. So then, okay, fine. Still you protect it. Then you get the money, then give it to somebody else. Doesn't matter. Okay. So governments are encouraging the creators to disclose their inventions into public so that we can promote the progress of science and useful arts which are engines for the development of the country. So the government, any government in any country, they're promoting, they're encouraging the inventions and innovations to come into practice and filing the patents. Okay. Anyway, I'll skip this. So why this intellectual property? As I told you, for economic growth, provides incentives for the technological innovation, attracts investment that will create new jobs and the opportunities. So now, who invents basically? So if you look at this in any given company or any university, 5 to 10% of the employees produce the 90% of the patents. Okay, so many company, you go to any company, or say maybe a big company, small company, university, or colleges. So many of the places, 5 to 10% of the people, employees will produce 90% of the patent. That means, so those 5 to 10% of the people are mastered or in the skill of inventing and patenting. So it's not an easy job. So I'll come to the stage in the last part of my presentation. Okay. So how can we become an inventor? How can we produce invention as an employees? How can we encourage invention as a business owners? So this is a question what comes to us. It's possible. Okay. Now, if you just look at that, so I just give a definition of the invention. So invention is nothing but inventions are created to make life easier, better, and safe. Simple. So this is an invention. If anything, any technology, any business method, if you make to make the life easier, better, and safe, that is invention. Anything new or different in the world made by people, that is an invention. And inventions are made to solve the problems. Our invention always to have a fun or good things to eat. For example, today if you want a cup of coffee, making a coffee is a tedious job. If you just go back to the 20, 30, 40 years back, it's very, very difficult to make the coffee. Then after that, it became a little easy. Today, people have invented a coffee vending machine. Just press, the touch screen, just press that one, cappuccino. Within a few seconds, you'll get a cup of cappuccino. You will light coffee. Anything you can get it. So that's an innovation, or that's an invention. People invented coffee vending machine to make life easier. But today, we are having a map, the Google map. Just to put a location from say from point 1 to point 2. So you can easily go. So just go back to the previous earlier years. So very difficult because you have to ask people how to go from here to there. And the people tell take left, go right, go 1 kilometer. So this is what the earlier. Today, because of the technological inventions, so people are made life easy. They made the inventions which are we can use the Google map is available, and the map is available, computer is available, or laptop is available, or the phone is available, and GPS is available. They made an invention to connect these three to make the map and navigation system. That is basically making the life better and easier. So there's a lot of things. I think if you just look at the example, there are many, many examples. Okay. And then, so this is what is called invention. Okay. So then just come to the, what is the definition of intellectual property? So anything, industrial and scientific fields is this thing, and phonograms and broadcast, there are also IPs, trademark, commercial names and designations. For example, name of the movie, the name of the person, name of the designation, that's also an IP. Or performance of an artist, maybe for example Kuchipudi or the Bharatanatyam. So maybe people will make, that's basically also an IP. Inventions in all field of human endeavor, that's an IP. A literary, artistic or scientific work is an IP. If you write a book, it's a copyright, that's also an IP. So a lot of things, I think not one, two, there are many things. Okay, so if you look at that, these are the kind of IPs. One is what is called patent. We have a trademark, we have a trade secret, we have a copyright, design registration, or geographical indications, a lot of things. So now what I touch is only patent. So if you look at the geographical indication, GI tag, I think many of you heard Mysore Pak. For example, if you heard of a Mysore Pak sweet, the Mysore is the place. So that's called GI, geographical, that is given. Maybe Calcutta Rasgulla is an IP, given a GI. Mysore silk saree, maybe tequila in the Mexico. It's a drink which is that tequila is the GI. So a lot of, I think there's a lot of places we are given the GI tag. So that's an IP. That particular place that is famous, so they get a geographical tag. That is called GI. Similarly, trademark, I think if you look at you use a pen, in the pen we have a trademark. And trade secret, for example, if you look at the Pepsi and Coca-Cola, that's a trade secret. So nobody knows what is that inside the Pepsi and Coca-Cola. So now, so if you come to patent, so what is a patent then? If you look at patent, so it's very simple. It's an invention. Patent is an invention where if you are simplifying any process or procedure of manufacture, that is an invention, that is a patent. Or you're making a new item from the known item, that is a patent. Okay, so that's a patent. For example, you have a turmeric. So process of making a turmeric paste from the turmeric, this thing is called the invention or the patent. The process of making coffee powder from the coffee beans is a patent. Or enhancing an efficiency or utility of an item. So today we have a chair, the wooden chair. So you put a wheel to the chair so that you can move around. You can just sit there itself, you can move around. Or you have adjustable height adjustable chairs. So enhancing the efficiency of a chair by putting the adjustable part, that is called the invention. I think probably you heard of a nail. So if you want to put a nail to a wall, it's a very difficult process, difficult task. Now today you just go to a fancy store, you can pay 5 rupees or 10 rupees, you get a nail, remove that plaster, then you can just stick to the wall. That becomes a nail. So today that is a patent. So somebody filed the patent for that. So that is called enhancing the efficiency or utility of an item. Or solution to a persisting problem in the technology. For example, I gave example of a navigation system. The technology, there is a problem. So today you can just connecting the GPS and the computer and the map. We have created this. I want to find the restaurants around my place. It's a very Herculean task to know which restaurants are good. Then you can go to a restaurant, give the point of contact, we call POI, point of interest. So that point of interest is filed as a patent. We have millions of patents are filed in the GPS navigation. Okay. Similarly, convert an item from one form to another form to get some benefit. That is a patent. For example, you have an aloe vera plant. So take the aloe vera plant. So you can use the aloe vera plant making the juice to treat the sugar patient. So you can use that is basically, or making aloe vera cream from the aloe vera plant is the patent, because we are getting some benefit there. So that is basically what is just a simple example I've taken, but that applies to any technology, any business or any method. Okay. So now, having said this, so what is the strength of the invention? So once you have got something, what is the strength of the invention? So what is the useful expected life of the invention? It should be minimum 15 to 20 years. At least if that is the strength of the invention, should be, if you want to have that one, you should have a 15 to 20 years of the your expected life. And it should be detectable, invention detectable. What is new compared to the current the literature? Or make the product less expensive. Okay. So give the marketing advantage. For example, if you look at today, so if you look at today, so a lot of the marketing advantage is one part. Then, so how do we write the problem? So rewrite the problem in 10 different ways and list the causes of the problem and look at what is influencing the product. So like redefine the problem again in order to come up with a different innovative solution. And set innovation goal post that have a variety of solutions to your problem between them. Okay. Then, so the 7 sources of innovation. See, one is that the unexpected success, unexpected failure, unexpected outside event. So this is one of the source. Or incongruity between the reality as it is actually is and reality as it is perceived. Innovation based on the process need. Changes in industry or the market structure, or maybe demographics, population changes, changes in perception, mood and meaning, new knowledge, both scientific and non-scientific. So these are some of the sources of innovation. So now deciding which areas to pursue. So identify the real problem. Identify real problem is important in finding the real solution. Maybe is there a customer need? Is it feasible? Can we generate significant revenues and profit from this? Does it play to our strengths? So what are the technical challenges would be faced to do this in the real world? So these are the couple of deciding which ideas to pursue. Okay. Now coming to what is patent, maybe I think all of you know, maybe many of you may be knowing this. Patent is nothing but a legal action that grants inventor a sole rights to their invention in return for making their invention or idea known to the public. So once the research happens, invention happens, you have to disclose that to the public. If you disclose to the public, the government of that country gives a legal action that this is your rights. So that is called patent. So now that means why you have to get this legal action. So maybe to stop others from producing, marketing and selling or importing the invention. So just in order to stop other people to use it, to make use of this, so you have to file the patent. Then it's a territorial right. That means once you get a patent in that country, so only for if you file in India, it is a territorial. That means in India it's protected. Outside it's not protected. If you file in US also, then US is protected. If you want to protect in all the country, you have to file the patent in all the country. That means in the, any country, whatever the country you file, that country is protected. And again, it's a time bound. We have a 20 years time for this. The idea is protected. After that, it's become free. Okay. Now, once you come to the patentability condition, so we have 3 conditions. If you want to know invention is done, research is done, then the 3 conditions must be fulfilled to get a patent. One is called the novelty, then inventive step, and the utility. So what is the novelty? So in whatever the invention you made, whatever the innovation you made, whatever the research you made should not exist in the current prior art. So the current literature should not be available. And also, previously not disclosed to public. It should not be disclosed to public by anyone, including you. And also, if any modification or improvement done in the current product or a process, or use of something old in a new different way, that is the novelty. So please keep in mind that the concept of novelty is very, very narrow in the patent law. It's very narrow. So people think that the invention should be very big. No, invention can be very narrow. So if it's better than the earlier one, that becomes a novelty. So next is the inventive step. When you explain whatever you have found, whatever invented, if you explain to somebody, someone who is expert in that field, it should not be obvious. If that is obvious to that person, that is not the inventive. So it should not be obvious to that person. Okay, so that is called the inventive step. So third one, it should be to have an industrial application. So these 3 conditions must be fulfilled to get the patent. Okay. So what can be patented? Anything. Product can be patented. Things. Processes can be patented. Way to make things. Methods can be patented. Way to do things. Improvements, better things. Maybe like a business method, service, software. Anything we can patent. There's no constraint on this. Okay. So patent life cycle is this. So you have an idea, innovation or research or invention done, and we have a patentability search which goes for about 2 to 4 weeks time is required. Then we prepare the application to file. It may take 4 to 6 months. Then file the patent with the patent office in that particular country. For example, in India, we have offices in 5 offices: Chennai, Delhi, Calcutta, Mumbai, and Delhi. So 4 offices we can file there. Then the examination will be done. Maybe people will go through that patent application. There will be patent examiners. So they'll check that. Then once they're satisfied with the condition, then they'll give the grant of a patent. So it may take typically anywhere between 2 to 5 years to get the patent granted. Any country. Okay. So for example, you just take the pen. So now we'll typically what we use. So patent, there's a patent for the fountain pen that could store ink. So how to store ink is there's a patent. Utility model. The grip of the pen is having a utility model. Or there's a design, small design done, like a shape of an arrow. That is industrial design. That is again IP. So trademark. So yeah, it could be any. So there's a trademark. So that means for each of the product, there are many IPs. Patent, trademark, industry, so many things. The example 2 is the CD player. So the invention of a CD player is by a patent. In the brand and the patent is a trademark. And design of a CD player is an industrial design. And content in the CD player is protected by a copyright. That means we have multiple IPs. Okay. So having said this, so now this is how the research happens. Research, PG project, UG project, IP workshop, you do whatever. So that gives the different things like a experimental and result-based invention, conceptual solution, design or algorithm, new product solution. So that leads to a patent. Okay. Yeah. So once you come to commercialization, so what we can do, we have two benefits. One is a tangible and intangible. And say intangible, directly revenue. It's an asset, IP asset. And we can create a jobs using this IP because we can create a company, we can make the job generation. And for institute, it becomes industry collaboration becomes easy. Intangible, positive immediate institute or company, technology for future generation, innovation culture among faculty and the student. Yeah. So licensing. So what license? You can license anything, whatever you invented, to commercializing university-based technologies. So this is how the goes. Inventions are there. Technology, the marketing, then innovation and design. So these four things will go together so that we can licensing steps are here. Patent preliminary information you have to give it. Patent licensing questionnaire they'll give it. You have to fill up that. Samples you have to give. Proof of concept, prototype. Then working on the next part to sell the technology. So these are the couple of inventions but done by Stanford University, which generated the revenue in big way. If you just look at the multi-million dollars, some of the $1 billion also, they generated from the invention done in the so they just took an example because they are very sound the technology commercialization wing. So this is the number of inventions and how the generation of the revenue and how the distribution of the revenue happens in the University of Stanford. Okay. So now, so with this I just stop here. So just I given the what is the invention and what is the innovation, other thing. So now let's come to this blue ocean strategy. Okay, so just I'll touch upon this. Maybe if you just look at the thing, there are 4 parts. One is the what are the forces behind IP creation, and then what are the IP opportunities in a blue oceans. Then third is the IP creation process, and then what is the integrated action plan. Okay. So what are the forces behind IP creation? So 3 parts. One is the IP strategy, and then the process to define the IP creation, and then the people. So these are the 3 fundamental main thing or forces behind any IP creation. Okay, having said this, so what is the IP opportunities in a blue ocean? Maybe if you look at today, the creation of new market is based on the old technology adaptation cycle. I call TALC, the technology adaptation life cycle. Okay. Now today, so if you look at there, it's a very typical bell curve which we use in our any industry or any organization. So in this bell curve, maybe if you look at the first part, we have innovators and early adopters. Then we have an early majority, and then late majority, then laggards. Now, the innovators and early adopters, maybe startups or others, maybe just if you go here. So now this is the creation of a new market supported by existing technology infrastructure. So blue oceans offer wide spaces for open innovation. Maybe you heard of what is the strategy and the blue ocean strategy, then red ocean strategy. So blue ocean strategy offers wide spaces for open innovation. Maybe, but you might use the existing IP to create the blue oceans. Maybe if you just take the thing, maybe the building a portfolio in the present that has the strategic value in the future is a very big challenge. For example, any company or any university, maybe many of the colleges or many of the institutions is lacking. So because they're not seeing what is the in the future, what is the blue ocean available. Maybe what they think is that today, if you just do something, you should get a money, you should get a value. Then that will not happen. Maybe what is required, you have to build the portfolio, which is presently you can build a portfolio, which is having strategic value in the future. Because that is a challenge. Maybe for any leaders, the real task is to get ahead and today's IP challenges and to build and leverage patent portfolio. So the challenge is to build and leverage a patent portfolio that sits in the tomorrow's growing market space. So you have to create, for example, any university, they lack in investing money and time for creating the future technology. So that's how we are lacking. So now you look at the blue ocean. So what are the opportunities available in the future? Maybe what people suppose if I want to invent something, I'll not do it because I know I'm not going to get the benefit out of it. It's not that. So institution should, or the research university should, or the company should invest money and invest time and create the blue ocean, using a blue ocean strategy, create the space, clear the portfolio, patent portfolio, which can use in the future. Maybe after 10 years or 5 years or 10 years, something like that. Okay. So that's what the blue ocean market is, where the blue ocean market is where active IP coverage is available, and it's basically it's a yet untapped market, untapped business. There's a lot of untapped business available. So if you look at today Tesla, so they're able to create a market space. So they invested money, invested time. They created the IP portfolio. They conducted the innovation. They did innovation. Today they're getting a benefit. Maybe they spent close to 5 to 6, 7 years or 8 years to create that portfolio. So then they saw the blue ocean or the market in the future market. So that is basically what is the blue ocean is. Okay. Then so how ventures should made needs to approach. So if you look at today, the ventures needs to approach the data and the information within their business to find untapped patent opportunities. Maybe we just look at here. So here we have a market segment and also written the technology life cycle, the talc position. So global market note, for example, annual estimate, and you look at today smart metering. I think you know smart meter today is very, very in high demand. So smart metering installation. If you look at today, electric smart meters market estimated at 5 billion in 2014, and is going to be a 22 billion market in 2020. Okay. Then similarly, if you look at the smart grid, utilizing smart metering installation. So market is smart home is close to 47 billion by 2020 today. And smart thermostat, 1.3 billion by 2020. If you look at the demand response, it's close to around 51 billion by 2025. Now today, and they look at another market is vehicle to grid and buildings, million by maybe 2 to 90 million by 2022. And similarly, home energy management devices is close to 100 million by 2050. So a lot of market. That means there is a basically here what I'm trying to tell is that technology adaptation life cycle should be properly utilized, where there should be a link between the IP of mature market technologies. That means there's an IP already available in a mature market. For example, there's a traditional company available. They have a traditional IP already available. That is called the mature market technology. And now new growing markets that can be leveraged. For example, today the autonomous vehicles are coming up, and then there's a technology available in the old technology. So how we can leverage the new technologies to combine with the mature technology? That's basically a blue ocean. Okay, so that is basically how we look at. Okay, so then, for example, if you look at the example, if you take it, a traditional energy firms now supporting the smart home and smart vehicle technologies. So maybe there's a lot of companies, for example, take a Kirloskar or many companies, there are a lot of traditional companies available. So those companies are supporting the smart home and smart vehicle technologies, whereas previously they were independent. So today they're coming together, mutually supporting each other, becoming an invaluable asset and a competitive advantage. So that's how the things are coming up. Okay. So now, so having said this, just a case study. This is one of the case study which I took to explain. So smart meter patent support tomorrow's smart home products. Maybe today people are talking smart city, smart home, automation, many things. So there are a lot of companies. For example, if you take the 2014 in Korea Electric Korea Electric Power Corporation announced that pilot system or vehicle to grid, where car owners can sell their electric vehicle battery power back to the grid. That came into existence in 2014. In the early adopter stage, this requires smart meters, because when you want to sell your power, what is generated when the moving vehicle, it requires a smart meter. And then associated smart grid infrastructure as a support. So V2G technology is supported by Honda with a certain plug-in hybrid vehicles, and is not driven by cost benefits for the consumer. That it is driven by support the overall power grid and identify when energy demands require additional power grid sources, such as from the connected vehicles. So this is one of the area where the early adopter cycle available. Okay, so this is one area. So if you just look at here, maybe key strategies for ventures in pursuit of blue ocean intellectual property. Maybe whatever the IP what I mentioned. So I call the blue ocean intellectual property. So if you look at today, the key business challenge is that if you look at the large ventures and the market increments, so mature markets, which are slowing in growth and lacking in R&D releases to cover the new market. This is because the large ventures, for example, take GE or the Cisco, many companies, large ventures. They're very mature markets which are slowing their growth and then lacking R&D releases. Whereas if you look at the new ventures and startups, the new market may have the uncertainty of customer adaptation. They're uncertain. But so future business and IP efforts may be market irrelevant. Similarly, when you come to the investors and venture capitalists, increase deal flow of high quality investment. Intellectual property as a core business intelligence is not fundamental pillar of all investment and use. Similarly, the patent assertion entities, they are called PIEs, and internal licensing teams. The generation of license revenue through quality intellectual property, that is their objective. Similarly, if you look at the key strength to leverage, deep and under market-specific patent portfolios already owned by the ventures, large ventures, which can be assessed by the internal experts. And similarly, when you come to the new ventures and startups, the ability to pivot quickly and ensure IP filings are widely covered to support long-term market standards, because these are the companies which is coming up, startups and the new ventures are coming up, where they're going to quickly ensure that IP filings are widely covered to support long-term market strategies. Similarly, when you come to the investors and venture capitalists, they're focusing on the one technology or market segment with a deep business and IP knowledge, which once established can be leveraged across the due diligence power. So this is how they work on investors. Okay. So now key IP actions. Maybe if you look at the large ventures, basically it's a mine and review portfolios for coverage against the new market users. And when you come to new ventures and startups, mine enabling technology portfolio and business trends to find optimum strategic position for both intellectual property and other thing. Okay, so this is how the blue ocean intellectual property is taken care. Now, when it comes to IP creation, so this is an IP engine. Like you should have a strategy. So what is your filing strategy? So for example, there could be a large entity or the startup and the new ventures or the investor, whatever it is. What is the filing strategy, IP filing strategy? And what is the patent equality and portfolio mix? So what is the portfolio, how do you want to build your IP portfolio? Then coverage of the foreign coverage and etc. Then next is the process. So how do you harvesting, evaluation, then filing, prosecution and maintenance. So this comes under the IP process. Then the people, engagement and the education. So maybe if you look at this particular thing, so integrated action plan. So one is the engaging a visionary IP team. This is very, very important. Today, so what is happening in many of the institutions, many of the research institutions, or many of the companies, big organizations or the medium organization, is that they lack the visionary IP team. They have a tactical team. So that means tactical team is that operation basically. So they say you give something, they'll execute it. That's a tactical team. But what is required for this particular thing for the strategy and the IP engine is that you should have the visionary team, IP team, with legal and IP skills, business vision and technical depth. Because this is very, very expensive people. So even in the academic institution, so we should have the people like a visionary IP team. Maybe the number will not be large. It could be maybe few number, maybe single digit. Maybe 4 or 5 people in the organization of 200. If I have a 200, my size is 200 people. So at least 4 to 5 people we call as a visionary IP team. So those are the people will work complete aspect for creating the IP portfolio, which is in a blue ocean. So they look at the current IP technologies available, maybe with others and with ours. Then see what is the blue ocean, what is required for the future. Then they're going to create that. They're going to work and enable to create the future IPs. Okay, so that means you have to mine and identify where alignment of intellectual property and business value is needed for the venture. For example, any company, for example, if you look at today, Schneider Electric, they are in the electric field. So they mine the existing portfolio. Then they want to see what is the business value needed for the venture in the coming years, maybe next 5 years, 10 years, 15 years, that kind of thing. Okay, refine and remain flexible as markets and legal climate evolve. So that means find the intersection of the market IP position, the new market, infrastructure, technology, whatever. So this is basically what is the integrated action plan required for any company, any venture, or any university or any institution. So now, so that means, as I mentioned, create the visionary team. It will not be enough to assemble a tactical team, which I already mentioned, which can be technically or legally find new patents. It will require a highly skilled team which can create a business vision of where the venture needs to go and keep the tactical team on task. So this is what I call visionary team is called. Understand the market. So every market segment and geography moves at different adaptation type pace. So visionary team must have both broad and deep understanding of the market to see the blue ocean trends emerging. For example, you look at today Uber or the Ola or you name anything. There are many companies like Tesla. So there are many thousands of startups available. So those people are working with this particular creating the visionary team and then working with the new market with the blue ocean. Okay. So now, so what is the anticipate? The team must be flexible in how it approaches and builds the portfolio. So IP portfolio. So treating IP assets and mutual fund. Basically, people think that if you create an IP, we have to spend money of 2 lakhs or 3 lakhs. Why should we waste money? So many of the institutions, many of the companies today, if you just go to your manager, if you go to your professor or HOD or institution head, people tell, no, this is very expensive, it's a totally waste of money, let's not do this. So creating the IP asset is creating like a mutual fund, like a systematic investment plan, what you call SIP. So create the IP. So in the blue ocean, the strategy using adopting that and creating in the new market, what is going to create IP is basically creating like a mutual fund. With a balanced portfolio that will cover the shift in legal and the business climate. Okay. For a visionary team, this translates into predicting and weighing the probability of market shifts and shaping the portfolio accordingly. So this is what is called visionary team. Maybe maybe just I know at least in a couple of companies, institution, how we are running. So most of the people lack in this one. So as soon as people say we want to create a visionary team, people say no. They don't want to invest money. They don't want to invest time. They don't give the space. But unless otherwise we do this, whether a university, whether an institution, whether an organization, creating this visionary IP team to create the portfolio, the patent portfolio for a future market. If we don't do that, then we remain like this. That means we're in the red ocean. That means any company, they're competing with each other. So they just tap his pie. So he is doing a revenue of 400 million. So get into his portfolio, tap the snatch his business, then you do the business. That is what is called red ocean. That are the institution. Today we are struggling for admission, struggling for the good people to join the college or the institution. Why? Because we are working in the red ocean. We are not working in the blue ocean. So now what is required? The institution, the top management, everybody has to think to invest time for a blue ocean creation. If you're able to create that, then the quality of the students, what you admit to the student becomes better. You are not taking away the other institution admission. You are creating a new opportunity, new portfolio where you get a people. So that is what the goal of the objective of the institution should be. Objective of the venture should be. Objective of the company should be. Okay. So with that, so I just stop here. So this thing is I taken another example. Or maybe just taken another example. So many of the companies are created today. Maybe if you just go to we are very creative people. They leave the organization. They leave the institution. They leave the universities. So what they'll do? They struggle. But they want to create something. Because they know the market, the future market. For example, I know at least the one case is Mahesha Pandit. So he was a very brilliant guy. He's a very brilliant person. And he was working with many companies. So where he was not able to create anything in that organization, maybe a very small way he can do, but he wanted to create something in a blue ocean. He foresees that there is a potential. We can create a market. But what did he do? He exited. He exited. He started his own. Then he's venturing into that new company and doing his own work. He is creating. Then what will happen? Maybe down the line 2-3 years, so his portfolio becomes stronger. So maybe IP portfolio or the innovation portfolio becomes stronger, or technology portfolio becomes stronger. So what will happen? The big company, which were not able to use No, I just take an example. Mahesh, if is there, sorry, I'm just using your this thing. So it's a similar kind of thing. For example, any X person exited from the company, he created the different space in the blue ocean. So what will happen? That company who was not able to use that person's the creativity, putting in the creative visionary team, not able to create. So you will buy that company, the startup or the new venture, what is done by this X person. You will buy that company. Big company will buy that because he is able to create the portfolio, and that is having a high market. That's what's happening now. Today, you look at any company, whether you take a GE, Cisco, Tata, name Infosys, name any company. So they buy the new companies. So which is started by the startup, which is started by the technologist, started by the business visionary. Many people have started small companies. So they buy those companies. For example, today if you look at take the Uber or the Ola, or the Facebook or anybody. So they buy the small companies. Why? Because the small companies are created the different space in the blue ocean market. They are technologically very good. They created the portfolio which is having a high market in the future or the current market. That is what is called a blue ocean in the current scenario. So now what will happen? So at the end of the thing, so the kind of people exit from the company or the fresh from this college, they start their own company, create the blue ocean the IP portfolio using the strategy. Then the other companies will acquire that, or this company will continue, whatever that will happen. So similarly, that should also happen in the institutions. So we should invest money because I believe that. I'm just doing that to some extent in our institution now, like currently. So we want to create the IP portfolio. We are investing small way, but of course we have a plan to do research park where I identify the visionary team. I'm already identified 1 or 2 people. We have recruited 1 person already for the visionary team, which we are going to do that in the coming months or coming years to recruit the visionary team whose job is to see where is the market, where is the portfolio, where is the technology, what is the technology required. So create that the IP portfolio or the mutual fund portfolio in the technology so that in the future that we can encash it. So that's exactly what we are trying to do. So which are going to do in maybe a couple of 1 months or 2 months or 7 months. We will going to create that research park, which is the goal of that is to create this particular IP strategy. So that's how we are working. Yeah? So I urge, so all the faculty who are here, maybe the people who are attending this workshop, so think, it's difficult. I know, understand the thing, it's very difficult. So the saying is easy, but doing is difficult. But just think over. If you don't do, what will happen? So somebody will tap the market. So the blue ocean. So because ocean, there's a huge, the future potential. There's a lot of things which is required. So other people, maybe Chinese will do, or the Israeli people do it, or Russia people do it. They create this the institutional working on that research. The companies are working on that. They create the opportunity, they create the portfolio. Then what will happen? We have to buy from them. And for the same thing, which you have to spend 100 rupees today, you have to buy 1 lakh rupees. Same technology. So now if you are able to create that opportunity, maybe it may not be useful to us. The next generation people may use it. Next set of people may use it, but still okay. But my thing is that, so we should create that portfolio, for a future. Maybe from the point of view of organization, from the point of view of institution, we should create and then use the opportunity. So that's what we got last 5 days. Definitely. The tremendous confusion and other part, but still my suggestion is that please think over then how we can contribute to creating this IP strategy, IP portfolio using the blue ocean strategy and the market which is untapped by your own area. So you may be working in the MBA department, you may be working in electrical, you may be working in computer science, wherever you're working. So you just see what is the untapped business area, untapped technology, untapped market. So just see what I can do. So use the blue ocean strategy. So this is what my appeal to all of you. I'm sure you can take it forward. You'll do it, and in your institutional benefit and in large country will benefit. Thank you so much for the opportunity. And if you have any question, you can just either put in a chat or you can unmute and you can ask me. Maybe a few questions I can take. Thank you so much.
Thank you,
Basaraj.
sir. Audience, please
Yes, sir.
pick up questions with our resource person. It is open for audience for question hour.
Any question, maybe our simple it is. So you can, or if you have any suggestion or anything to add to this, also please feel free. I'm open for that. Mahesh, anything to add here? Mahesh?
No, sir, it was a fantastic session. Yes, there are a lot of opportunity. Only thing I want to remind the participants is that we discussed about barriers to imitate blue ocean strategy, right? We need to create barriers, otherwise everyone will jump in. So patents is one great barrier. No one can easily capture your blue ocean. So patent is surprisingly easy in the sense that I'm not telling you that it is trivial or anything like that, but there is so much help available to do patent. It makes your journey easy. So I hope that we have communicated those points over the course of this, and you have tremendous opportunity here. Next 35 years belongs to us. I keep telling that. So um, uh, we have a lot to do, a lot of opportunity, a lot of encouragement and support. It's only innovation that can take us to the future. So, yeah, so you have fantastic opportunity on your hand because you can shape the young minds even before they come to us. Okay, so as educators, yeah, please think out of the box. You should around the box, inside the box, outside the box, or declare that there is no box. Do whatever, but influence people to think differently. That's the only appeal I have. So, yeah.
So any other questions? There's no other question. Thank you so much. Thank you so much. Thank you all.
So thank you, sir. We will have a brief summary of today's session by Dr. H.R. Mahadeva Swamy. He spoke on new possibility with blue ocean. He opened a statement by connecting science and technology and importance of research and innovation in job creation. He spoke about improvement in reach today various projects and innovation. He talked about automation of knowledge, data sciences, use of IoT and data collected, and he talked about cloud computing and software updates, and he talked about potentially economically disruptive technologies and intermediate impact technologies, and he talked about importance of research in academia and university and future projection of innovation comparison between innovation and invention, and he talked about enhancing the efficiency and utility through patents. So he talked about 7 sources of innovation. He extensively covered on the topic of forces behind IP creation and key strategies of ventures and IP engine and integral action plan. And he concluded with the example quoting Mr. Mahesha B.R. Pandit about Blue Ocean strategy and his venture in marketing. And he concluded with we have to have create a good profile for a bright future in Blue Ocean strategy. I thank our principal and today's resource person, Dr. Mahadeva Swamy, on behalf of all the coordinators. especially Dr. E. Basuraj and the Department of Mechanical Engineering on behalf of all the participants. I thank you very much, sir, for your wonderful session.
Thank you. Thank you. Thank you. Thank you.
I request all the participants to log on to participants web portal in Atal AICTE portal, and you have to exercise your feedback. That is mandatory for taking test. I request all the participants to complete this assignment before 11:55, and we shall have test from 12 noon, and it's about for an hour. Exactly at 1 o'clock you have to within 1 o'clock you have to complete, and at 1 o'clock we shall have a valedictory function of this 5 days FDP. Instead of afternoon, we shall have an extended session from 1 o'clock. Between 1 and 2, this valedictory program will be conducted. I request the active participation of all the participants. Thank you.